Hello friends. So today we are going to start with a new topic, that is vector algebra. Okay. See, this vector algebra topic already was studied in detail in the physics subject. Okay. So this is just a part of that. Okay. So you know, I think, better about the vector algebra. So in the vector algebra there are two quantities. So first quantity is what? Scalar quantity, and second quantity is what? Vector quantity. Okay, I think you know this. Then what is meant by scalar quantity? A vector, or I can say a quantity which has only magnitude. A quantity which has only magnitude is called as scalar quantity. Is called as scalar quantity. Means this is only having magnitude. What? Magnitude. Okay. Whereas what is meant by vector quantity? A quantity which has magnitude as well as direction. Magnitude as well as direction, then it is called as vector quantity. Okay. So this vector quantity means what? It is having magnitude and direction, and therefore it is called as, or that quantity is called as vector quantity. Okay. So these are the definitions of scalar quantity and vector quantity. Okay. So in this topic you are going to learn the three major concept. That is what? First concept you are going to learn is scalar or dot product. Scalar or dot product of two vectors. Second, vector or cross product of two vectors, and third is scalar triple product. Third one is what? Scalar triple product. So these are the three types, you can say, to take the product of the vectors: scalar or dot product, vector or cross product, and scalar triple product. Based on these three types, okay, the maximum question will ask on these three concepts only: scalar, vector, and scalar triple product. Okay. But this year, okay, so as they are saying 30% syllabus is reduced, so from this third one, scalar triple product is reduced, but we are not going to reduce. Okay, here we will study that scalar triple product also. Okay, because that may help you at the time of competitive examination. Okay, so before starting with scalar, vectors, and scalar triple product, we will see some basic concept, okay, of the vector algebra. Okay, then we will come towards this major types, that is scalar product, cross product, or scalar triple product. Okay, now first we have seen the definition of vector, scalar quantity and vector quantity. And the next concept is position vector. Position vector. Okay. Now let us see what is meant by position vector. See, so this vector algebra we are dealing with the three-dimensional geometry, means three-dimensional plane. So here I have taken a plane, or can say a space, plane or space. In this plane or the space, we are going to take one point P, and that point is x, y, z. That point P is what? X, Y, Z, and that point is joined with respect to origin. It is joined with respect to origin. Okay. Now here we form one vector. That vector is what? Vector OP. Okay. Here we form a vector. That vector is what? Vector OP. Now this vector OP is called as position vector. Why? Because this vector OP, it is having initial point O and terminal point P. Okay. Or also you can say initial point O. This terminal point is also called as end point P. So therefore this vector OP is called as position vector of the point P. Okay, how we have to read this? This is vector OP. We read as what? This is the position vector of the point P. Position vector of the point P. So simple. Position vector means what? Which is having initial point and the terminal point. Okay. Next concept. Direction cosines. Direction cosines. Okay. I think that direction cosines concept I will explain in the same diagram. See now this vector OP I will denote by some other name, that is vector R. So this vector OP I have denoted with what? Vector R. Now how you will read this? This vector R is the position vector of the point P. This vector R is the position vector of the point P. So again here in the three-dimensional plane I have taken a point P which is joined with respect to origin O. Then here we form the vector OP and that is denoted by the vector R. Now due to the vector R, okay, so this plane is divided in three angles. Those angles are, that is, I think alpha, beta and gamma. Alpha, beta and gamma. Alpha is angle, it is in the positive direction of x-axis. Beta, it is in the positive direction of y-axis. Gamma, it is in the positive direction of z-axis. Okay, therefore this alpha, beta and gamma, these are called as direction angles. These are called as what? Direction angles. These are called as direction angles. But we are seeing the definition of what? Direction cosines. Now these angles alpha, beta, gamma, if these angles, if I write with the cosine function, means what? That is cos alpha, cos beta and cos gamma. Now this cos alpha, cos beta and cos gamma, now these are called as what? Direction cosines. Direction cosines. Okay, so cos alpha, cos beta and cos gamma, these are called as direction cosines and these are denoted by L, M, N. L is equals to cos alpha, M is equals to cos beta, N is equals to cos gamma. You have to remember this. So that formula is important to solve the 1 mark question. Okay, so they will give you the angles and they will say find the direction cosines. That time you have to use that formula. L is cos alpha, M is cos beta, N is cos gamma. Okay, so this is the concept of direction cosines. Okay, next we are going to see the types of vectors. Next we are going to see is what? Types of vectors. In that there are several types. Okay, you might be studied some of the types in the physics also. So I will take the first type is zero vector. First type is what? Zero vector. Now here what is meant by zero vector? So zero vector means it is not like that whose magnitude is 0. Here I am going to define in other way. A vector whose initial point and terminal point coincide. A vector whose initial point and the terminal point coincide, and such type of vector is called as zero vector. Is called as what? Zero vector. For example, see, suppose this is the initial point. So for this I will take a dumbbell shaped curve. So if I start with this curve, okay, and I have taken the curve, again it joined into the same point. So means what? Initial point and the terminal point, they coincide. Therefore such a vector is called as what? Zero vector. Second type, unit vector. I think you know well about this unit vector. a vector whose magnitude is 1. A vector whose magnitude is 1, such type of vector is called as unit vector. Okay. Now for example, we are finding unit vector of this vector A. Unit vector of this vector A. Then notation of unit vector is what? A cap. Notation of the unit vector A is what? A cap. And there is a formula to calculate the unit vector. So that formula is A cap is equals to vector A divided by magnitude of vector A. Vector A divided by what? Magnitude of vector A. So again this formula is very important for 1 mark. Okay. So they will give you any vector and they'll say to find out the unit vector of it. Okay. Next type, third type, that is equal vectors. Equal vectors. When the two vectors are equal, suppose I am having vector A and vector B. I want to say this both the vectors are equal. So when we call it as equal, when they are same in magnitude and same in direction. Okay, if their magnitude and direction is same, then those two vectors are said to be equal. Said to be what? Equal. Next, fourth one, co-initial vector. Co-initial vector. Co-initial vector means what? Two or more vectors having the same initial point. Means what? Suppose I am having initial point is O here. Through this initial point, there is a vector A. Through the same initial point, I am having another vector B. Through the same initial point, I am having vector C. So for vector A, vector B, and vector C, their initial point is same. Therefore, this vector is called as what? Co-initial vector. Co-initial vector. Next, fifth, collinear vector. Collinear vector. Now you know about what is meant by collinear points. What is meant by collinear points? If there are two or more points, if they are lying on the same line, then those points are called as collinear points. Okay. In the same way, what is meant by collinear vector is, okay, there are two or more vectors. If they are parallel to the same line, but irrespective of their magnitude and direction. It means what? See, suppose I am having a line here. On this line, I am having here suppose vector A. Okay, this is vector A, this is vector B, and this is vector C. Okay, suppose vector A is in this direction, vector B is in this direction, vector C also in this direction. Okay, but if you observe in this vector A, vector B, and vector C, their magnitude is not same. They are not same in the magnitude. As well as vector A is in left hand direction, whereas vector B is in right hand direction. So again the direction is also not same. But vector A, vector B, and vector C, they are lying on the same line. It means what? They are parallel to the same line. Therefore, these vectors are called as collinear vectors. Okay. One more type we are going to see, that is negative of a vector. Negative of a vector. Now negative of a vector means what? A vector having the same magnitude as that of the given vector and direction is opposite to that of it, then that vector is called as negative of a vector. For example, simply I will just try to make you understand the definition. See, suppose I am having magnitude of vector AB is equals to 4. Magnitude of vector AB is equals to 4. Then negative of this vector AB will be what? Minus 4. Why? Because they are same in the magnitude but opposite in the direction. Opposite in the direction. Or suppose if I ask what is the negative of the vector AB, it will be what? Minus BA. It will be what? Minus BA. That is called as negative of a vector. Okay. So these are the types of vectors. Maybe I have not written any definition here, okay, but it will be given to you. So with this video I am going to send you the notes also, the whole notes of the topic, okay, as already I have done it with continuity and differentiability. Okay, so next concept in this is what? Vector addition. Vector addition. Now how to add the vectors? Okay, see this vector addition we are going to see with the help of triangle. With the help of triangle. So therefore it is also called as what? Triangle law of addition. This is also called as what? Triangle law of addition. Okay, now see. If you observe here in the triangle I have taken the 3 points A, B, C. There are 3 sides AB, BC and AC. If you observe here, AB and BC in the same direction. AB and BC in the same direction. Whereas AC is in the opposite to other 2 sides. So therefore, the vector addition can be written as, so that vector AB plus vector BC is equals to what? Vector AC. So how to write the vector addition? The 2 sides which are in the same direction, that will be added and that equals to the other side which is in the opposite direction, and this addition is called as triangle law of vector addition. This is called as what? Triangle law of vector addition. Triangle law of vector addition. Okay, next concept is component form. Next concept is component form. Now see, this is one of the important concept. Okay, so again I will take a plane, or you can say it is a space. Okay, so in this plane or space I am going to take a point on x-axis, on y-axis and z-axis, that is A, B and C. Okay, now here this OA, OB, OC all are having the magnitude is 1. All are having the magnitude is 1. Therefore this OA is equals to OB is equals to OC is equals to what? 1. So all are having the magnitude is 1. So if magnitude is 1, then those vectors OA, OB and OC are called as what? Unit vectors. Are called as what? Unit vectors. And now those unit vectors we will denote by I cap, J cap and K cap. So I cap, it is along the positive direction of x-axis, J cap, it is along the positive direction of y-axis, and K cap, it is along the positive direction of z-axis. Okay, then I am going to take a point P in the plane. I am going to take a point P in the plane, and this point we are going to join with respect to origin O. Then here we form a vector OP. Here we form a vector OP, and now this vector OP is called as what? Position vector of the point P. Why? Because it contains initial point and terminal point. So therefore this vector OP is called as position vector of the point P, and this position vector of the point P, or that vector OP, can be written as, see, any position vector can be written in the component form. How? Now see the coordinates of the point P, that is x, y and z. Okay, so in the place of x coordinate, okay, which unit vector is there? I cap. So this is the x coordinate, along the x axis we are having I cap, along the y axis we are having j cap, along the z axis we are having k cap. Therefore component form can be written as x into I cap plus y into j cap plus z into k cap, and this is called as component form of a vector. Component form. Okay. In this component form, okay, or let us take one example. Suppose we are having the point is 2 4 5. 2 4 5. Now this point we want to write in component form. So how to write this in component form? See, now x coordinate is 2, y coordinate is 4, z coordinate is 5. So keep in mind, always x coordinate you write it with I, y coordinate with j, and z coordinate with k. So therefore this can be written as 2I plus 4j plus 5k. Okay. Suppose now this is minus 4. Then here you will write 2I minus 4j plus 5k. Okay. Now one more thing I will explain here. In this component form, if we write only xi, yj, zk, so these are called as vector components. These are called as vector components. And if I write only x, y, z, then these are called as scalar components. These are called as what? Scalar components. Okay. So for today's class, I think these concepts are enough. In the next class, we will derive one of the derivation, okay, that is section formula, and then we will solve some of the examples. Okay, thank you.